as I already said, it is so great to see a nice crowd, familiar faces and new faces. Hopefully this is the Zoom meeting you meant to attend. Workshop 1, all about the loads. We actually are postponed the exciting discussion on non-structural controls into our next workshop, which I'll mention more coming forward. So this is being brought to you by Charles River Watershed Association. I think we are familiar to many of you, but as I said, I see some new names, and I think we're branching out beyond our watershed with this topic, or I know we are. So CRWA's mission is to protect, restore, and enhance the Charles River and its watershed through science, advocacy, and the law. Our work does extend beyond the watershed, where we're looking at statewide policy, or in this case, a statewide permit. We are actually one of the country's oldest watershed associations, founded back in 1965. So that's kind of exciting. We work in very close partnership with the 35 municipalities, or most of the 35 municipalities in our watershed, as well as with EPA and DEP. We have an interdisciplinary staff, so folks who are experts in science, experts in the law, and experts in stormwater planning. We have 4 main program areas that you can see there. So obviously this workshop is coming to you out of our stormwater program. Next slide. So hopefully we'll jump into the meat of it in 5 more minutes. We have a really in-depth presentation. Questions will be answered. I can guarantee you that. A really in-depth presentation that our partners at Brown and Caldwell put together. So we definitely want to get to that ASAP. And then at 2 o'clock, we'll have breakout rooms. Those will just be really quick breakout rooms. Something will pop up. You guys should be able to choose your own breakout room. Room number 1 will be for folks in the Charles, and room number 2 will be for folks in what we're calling the Lake and Pond communities. So those of you that have Appendix F requirements because of a Lake and Pond TAMDale in your community. Have time for questions, and then wrap up by 2:30. Next slide. So this is the team. I already introduced myself. Julia, do you quickly want to introduce yourself?
Hi, everyone. My name is Julie Hopkins, and I'm the Communications and Outreach Manager at CRWA.
Okay. Matt?
Sure. I'm Brown and Caldwell's Stormwater Technical Lead for New England, and also Brown and Caldwell's National Innovation and Technology Leader in our wet weather practice area.
Excellent. Andrew?
Good afternoon. I'm Andrew Goldberg. I'm a project manager at Brown and Caldwell and a water resources planner.
Excellent. And Stephanie is on the team. Is Stephanie on the call, or are we just introducing?
Yep, right. I'm here.
Okay.
Yeah, hi, Stephanie Alamina. I am a water resources engineer with Brown and Caldwell.
Great. Thank you, guys. And I mentioned we have 2 special guests in the world of MS4 permits. These are our MS4 celebrities. So from Mass DEP, we have Laura Schiffman, and from US EPA, we have Newt and Tedder joining us. Do you want to maybe briefly actually take down the screen share, Andrew, so that everyone can see Newt and Laura a little better? All right. Newt and Laura, I will turn it over to you.
Who's talking first? I guess I'll go first because I spoke first. I just want to, I'm really excited for this. I think it's a great opportunity for not only Charles River Watershed, but most anybody dealing with phosphorus, just with phosphorus pollution and trying to curb phosphorus pollution across Massachusetts. I'm looking at about 60 or so people on the call, which I think is absolutely great. I'm really excited about the amount of people that are interested in this topic. I'm excited about what you're going to learn, and mostly about the discussion that you all are going to have together about tackling a really, really complex problem in the most like economical way possible. So that's what I think all you guys are going to get out of this. I'm here to support and answer questions as things come up. I won't be on the calls in their entirety, but I will be available to answer questions and stuff as they come up. Where EPA is like very invested in not only the Charles, but all communities that are dealing with, or all the water bodies that have nutrient pollution and trying to clean that up. So this is a large step forward in doing that. And I'm just excited to see all the faces, a lot of people that I've seen before and some new ones as well. So I'm just here to lend my support. I'll turn it over to Laura.
Thanks, Newt. Yeah, I can also just echo this. I'm really excited to see so many of you on this call today. This is a big success. I see 67 participants. That obviously includes the project team, but the majority of you are municipalities, which is fantastic. So we're really thrilled. Just as EPAs, we're really thrilled that you're interested in this topic. That this is the kind of, we know this is a really big endeavor and a big permit requirement that's complicated and complex. And so we're grateful to CRWA and Brown and Caldwell to sort of help you guide you through this. And, just like Newt, I'm also available for any questions, any sort of input that you need. And, hopefully we're able to support you through this process as you're working to, to meet some of the permit requirements related to the TMDLs. But yeah, I'll turn it over back to CRWA and Brown and Caldwell.
Thank you guys. Thanks so much for coming in and giving your introduction and perspective there. And we appreciate you taking the time. And I know you guys are not staying for the extent of the meeting, but thank you for your words. So very quickly, so we can get to the topic you're all here to hear about. This project or this workshop is happening as part of a project that was funded by Mass DEP's FY22 MS4 Municipal Assistance Grant Program. So thank you to Mass DEP for our funding. Folks in the, I know folks in the Charles, maybe some of you beyond, may remember that last year we developed a phosphorus control plan template. This project will also build upon that, connect to that, as well as actually build upon that template. We conducted a survey. I got input from you folks on what you wanted workshops, what workshop topics would be helpful. So that's essentially how these workshop topics were decided upon. And it seems like it's true based on the attendance we got. These are topics you want to hear about. So this is the first in a series of 3 workshops, as well as a dedicated Q&A session with our regulatory partners. The final element of the project is a cost-benefit resource based on recent real-world examples of green infrastructure and BMP construction in Massachusetts. So that is why we recently put out a call to folks that if you've built some of these, if you've overseen the building of some of these in your community, we would love to have that information from you. What did these BMPs cost to put in the ground in your community? Real, local, recent data that we can compile and then share with the group to give some good information on the cost of construction, as well as related to the phosphorus control received and other benefits from those systems. Next slide. So I mentioned this is the first workshop. Workshop 2 will focus on private BMPs, how to get credit for those. Many of you have many of those already in the ground. So what's that process like? And that's also when we'll now cover non-structural controls. And so that's about a month from now, beginning of April, and then workshop 3, public BMPs, and that's the beginning of May. And then our final Q&A session, where you can ask the regulators. If you already have a question, we have a form on our website where you can submit questions so that we can have some questions lined up in advance so that folks can prepare for that and be best able to answer your question. So hopefully we'll see you at all of those. Just a call back to the phosphorus control plan template that I mentioned that we developed with funding from DEP in the previous fiscal year grant round of this MS4 Assistance Grant Program. One of our goals is to tie things presented in this phase back to the PCP, update the PCP as needed, so that it really is a useful resource to you all. And that is currently available at our website. So that's the link. Next slide. All right, so we are going to do a poll, which I think Julia is going to launch. So you should see it on your screen. And once we launch that poll, then we can dig into the more technical elements.
One moment, I think we're going to try to launch the poll, but I'm experiencing a technical difficulty, so I need 30 seconds to get this going. Thank you.
Okay, no problem. All right, well, the poll's questions are pretty wordy. Actually, while Julia does that, I should take one pause and just let folks know, please feel free throughout the presentations to put any questions in the chat. If you have a question, don't want to forget it, feel free to put it in the chat. Oh, and here we have our first poll popped up. I personally would consider myself this familiar with the MS4 general permit Appendix 4 requirements as they relate to my municipality. So just select your circle there and then hit submit. Give folks a few seconds to answer. Okay, all right, so it looks like folks are kind of hovering around the two middle choices, somewhat familiar, very familiar. I love I could transcribe the permit in my sleep. Hopefully that's our next presenter, Matt. I'm guessing it might be, or maybe Newt and Laura. Or it's someone we should get to present at a future workshop. And then a few not familiar at all. Great, okay, great. So I think this, Maria says it's Newt, yep. Excellent. Are you do we have a second poll to launch, Julia? All right, second poll coming at you. What is your community's progress preparing the written PCP due by June 30th, 2023? So hopefully one of these best describes where you feel your community is at. All right, do we have a good number of responses there? All right, so the highest reported in process with permit year 4 requirements. Okay, great. Pieces developed as required by the permit, 26%, 22% outlined. Very few of you have not started yet. So that's great. All right, so it seems like folks, whether it's one or more elements, it seems like folks are getting going with this. All right, our last permit question, or excuse me, our last poll question about the permit. How can we help? What pieces of the PCP do you hope to get help from in these workshops? And this is just a single answer again. We should have brought some music for the poll questions. All right, should we do last call? Last call on the final poll. Get your answers in. We have a comment in the chat. I wish all was available. Okay, top answer, understanding EPA's calculations. Okay, you folks are in the right meeting. This, you will you will have a deep dive on some of these today. And what do we have second? We have understanding cost benefits and how they feed into implementation. Great, and then lots of interest for all the other topics. I'm seeing also just comments that people really want to see all of these. So the good news is all of these plan to be covered. I think we were just sort of hoping to get a sense of where people's really priority interests lie. So we're not gonna, this was more of just getting a sense of the interest. Excellent, all right, with that, I am gonna hand it over to Matt.
Thanks, Julie. So how are we going to do this, Andrew? Are you going to pass control?
You are now a presenter if you're able to pull up your screen, and if you have any trouble, we're here to help.
Okay, but I don't have the slides. Okay. So do you mind sharing? I'll just ask you to advance through.
Happy to. Let me pull that up.
So while Andrew's getting started, I guess I can go ahead and begin. I'm really excited to be here and talk with y'all about developing the phosphorus, understanding EPA's baseline phosphorus load calculations, and was happy to see the response in the poll there. We're going to be covering sort of a number of these topics, the phosphorus control planning area, the development of the loads, when to request a baseline revision. And this slide here just kind of shows the progression of the workshops and what we're going to be talking about. All these, everybody's here today because they have a stormwater phosphorus load reduction requirement, or they're working with a community that has one. We're going to talk about what that requirement is today in this workshop. And then in future workshops, we're going to be talking about how you can satisfy that requirement through non-structural BMPs, and structural BMPs, both on the private side and the public side. And I've spent a lot of time working with clients, kind of navigating these different issues. I spent a lot of time talking with EPA, both Newt and Mark Voorhees, and they've been really helpful in helping me to understand some nuances of the permit. And I'm going to try to point some of those out because there's some things that aren't really very obvious. And there are even some inconsistencies, and that I'm hoping through this workshop, I can help make some of those things clearer to you. And I just want to make it clear that I'm going to be pointing out some of these nuances or inconsistencies. And I don't mean them as a criticism of the permit or EPA. The permits, this is a pretty complicated thing to implement. And this is their first iteration of it in the permit. So, it's a very challenging thing to do. And I'm really happy to be here today to try to help, clarify some things that hopefully, will be helpful to you. So next slide, please, Andrew. Okay, so this workshop, we're really talking about the phosphorus load reduction requirements. And these are, so to determine what that requirement is, you take your 2005 baseline phosphorus loads and you multiply that by the phosphorus reduction requirement. And then you need to add on any phosphorus load changes due to development from 2005 to present. Now, there's just a couple of things I want to point out about this. One of which is that the baseline phosphorus loads are for 2005 conditions. That's true for the phosphorus, for the Charles River communities and also the lake and pond communities. Now, for the lakes and ponds communities, the TMDLs for those were developed, I think, from 99 through 2010. But in conversations with Newt, he suggested that it would be appropriate for the lakes and pond communities to use 2005 as a baseline condition. And that kind of makes sense because there's really good GIS data through MassGIS for 2005. The other thing I wanted to point out is that any phosphorus increases that you have due to development are going to add to your phosphorus load reduction requirement. So those will need to be offset by BMPs. Okay, next slide. Let's just talk briefly for a second about the baseline phosphorus load calculations for the Charles River communities. The baseline 2005 baseline phosphorus loads and the phosphorus reduction requirement was provided by EPA in the permit for all the Charles River communities. One thing the Charles River communities need to do, though, is select what their phosphorus control planning area is. It can either be your jurisdictional area or the urbanized area within the jurisdiction. And the distinction between these that might sort of help you guide you in your selection. Well, first of all, there are some jurisdictions that are completely urbanized. So it's not much of a choice in that case. But for the communities where only a portion of their jurisdictional area is urbanized, there's an option. And if you select your jurisdictional area, you can avail yourself of credits, phosphorus credits that take place anywhere within your jurisdiction. But if you're using only the urbanized area within your jurisdiction, you're only available, you can only take credit for activities that are take place within the urbanized area. Okay, next slide. Okay, so for the lakes and pond communities, only the phosphorus reduction requirement was provided in the permit. And that's because the watershed boundaries were not available to EPA when they developed the MS4 permit. So the lakes and pond communities need to develop their own baseline phosphorus load. They also need to select their phosphorus control planning area. And again, like the Charles River communities, it can be either, it's either the jurisdictional area in the watershed or the urbanized watershed area within the jurisdiction. Now, one thing to note is the permit talks about the loads needing to be calculated for watersheds, but it is probably also going to be acceptable to calculate them for stormwater catchment areas. And this might be something you want to consider. I've talked with Newt about this, and the feedback I've gotten from Newt is that technically it would be okay to develop your loads for just your urbanized stormwater catchment area. And the reason why I say it may behoove you to take that approach is that it's likely to be a smaller area than would be your entire jurisdictional area within the watershed or your entire urbanized area. So that's something that you might want to consider. And we'll talk a little bit more about that. So the permit talks about doing it at the watershed level, but it does look like that you could do the catchment, just do catchments. Okay, next slide. All right, so before we get too far, why are we talking about baseline phosphorus loads? Well, there's a few reasons. First of all, phase 1 of the phosphorus control plan is coming up. July of 2023. And defining the scope of your phosphorus control plan area has to be done this year. And the lakes and pond communities need to develop their baseline loads this year. And Charles River communities that want to request a revision to their baseline loads should do that this year. So this is kind of timely. These decisions and analysis needs to be done fairly soon to meet the deadline coming up in July for the year 4 of this permit. So the lakes and pond communities need to do these baseline phosphorus load calculations. As I mentioned earlier, EPA did not perform them because the watershed boundaries were not available at the time of the permit. Now the Charles River communities, you may want to request a revision of your baseline loads. And I'm going to talk a bit about that when, what kind of circumstances you might want to do that. The other thing, just generally speaking, is that I think it's nice to have transparency so that communities know how these values were calculated. Let's face it, this is a pretty expensive proposition. And, I think it's important that you have information available about how these values were calculated in the first place. Now, the other thing that may even be a more compelling reason for the Charles River communities to be interested in this is that when you calculate the changes in phosphorus loads from 2005 to present conditions, the permit prescribes an approach that's sort of a project by project approach where you would go through and do this accounting process for every development project, redevelopment project that happened. You look to see how your loads changed in the system. But doing this for looking backwards 17 years and doing this project by project approach could be really tedious. You may not have the data to support that. So an alternative approach would be acceptable by EPA. And that is to basically use this same approach used to calculate the baseline loads, but do it with updated GIS layers. Instead of using 2005 GIS layers, update your GIS layers to current conditions. And these layers principally are your impervious area and your land use. Those are the ones that are most likely to have changed since 2005 that would affect your phosphorus loads. Now, if you update those layers, you can just use this process to calculate your loads for current conditions. And that's likely to be a lot easier than this project by project approach. Okay, and one last reason that's not on this slide about why it's, I think, helpful to talk about this baseline phosphorus load calculation is that, as I mentioned earlier, there are some things that aren't quite clear in the permit. And being able to kind of share those, I think will probably help you guys as you move forward a little bit in the development of your phosphorus control program. Okay, next slide. All right, so let's talk about requesting a revision of the baseline phosphorus loads. And this applies to the Charles River communities. The permit actually has some language about how to do this and when you would do this. So the permit says that you can submit more accurate 2005 land use data if you'd like to request a revision of your baseline loads. In my experience, another area that you might want to request a revision would be based on your impervious area, and also for areas that are not under your jurisdiction, like properties owned by DCR or DOT. And the reason why I say this, and I'm going to talk about these layers that MassGIS developed for 2005. They've got some really good layers, land use, impervious, but they're not perfect. And it may behoove you to go in and just review those to see if you think they're accurate, especially the impervious area. There are some places where, like ball fields. So the approach they use for developing the impervious surface GIS layers is a remote sensing based approach. And they use different wavelengths of light and try to figure out what's an impervious surface versus a pervious surface, but it's not perfect. Shadows can throw things off. Some different types of ground surfaces, like maybe ball fields, can show up as being impervious. And let's face it, it's going to be expensive to implement the phosphorus control plan. So every pound of phosphorus that you can reduce your target can save you a lot of money. And we're going to talk more about the costs later. But those costs could be on the order of maybe $100,000 per pound of phosphorus removed in new construction costs. So it's pretty, So, you know, I think it's a worthwhile effort to see if your baseline phosphorus load is accurate. So you can submit a request in year 4 of the annual report, and you'll submit the layers that you would like them to use to update the baseline load. And until they give you notification that they've accepted that, you need to proceed with the reduction requirements that are in the permit. Now, there are some benefits of estimating your baseline phosphorus load. And, you know, for one thing, it's helpful for understanding where your phosphorus is being generated. It can also be helpful for things like, let's see, well, I'll get into a little bit more in updating some of the GIS layers. And as I mentioned earlier, I think one of the main reasons you may want to request is that if you find that your non-jurisdictional areas were not calculated correctly. Can you go to the next slide, Andrew, and I'll show you what I mean by that. So EPA calculated the amount of land area within all of the Charles River communities that have lands that are owned by DCR or DOT. And one thing that you should check this table and see if these numbers seem accurate to you. If they're not, that may form a basis for requesting a revision to your baseline loads. This table here is from a spreadsheet that Mark Voorhees provided to me. This was part of his calculations for the baseline loads for the communities, and so I just extracted these values. And this presentation is being recorded, so don't feel like you have to take notes on everything. You can always go back and take a look at this later on. In fact, there's a lot of content here, so if you don't catch things, you'll be able to watch it again. And I'm also available if you ever want to give me a call or shoot me an email and try to provide some clarification too. So next slide, Andrew. So let's talk about development of the baseline phosphorus loads for the lakes and pond communities first. So you have two options. Option 1 is to use the methodology in the MS4 permit, which is in Appendix F, Attachment 1. And it's pretty straightforward. What you do is you calculate the land use, the amount of land you have in each of your different land use groups in your watershed or your watershed catchments. And so you can see table 1-1 over here on the right-hand side. We've got a number of different sort of land covers listed here. These are sort of like land use groups: commercial, industrial, high density, density residential. What you would do is you would take your watershed, figure out what are your areas for each of these different land use covers, and then you would multiply them by these composite phosphorus loading export rates. That's what PLER stands for. And so that's relatively straightforward. You know, you can calculate your loads for each of these different land use types. You sum them together, that's your total load. The thing is that table 1 makes a lot of assumptions about your land use, your impervious area, your soil types, and these may or may not be representative of your watershed or your catchment. For example, that first column in the table is your directly connected impervious area. You may be higher or lower than that. And if you are lower than that, you may be using a phosphorus loading export rate that's maybe higher than you should be using. So this is option 1 is one approach that you could take. But the other approach you could take is to use the methodology that EPA used for the Charles River communities. And that's going to be the main focus of this discussion. Now, one thing to note is that the Neponset River Watershed Association wrote a really nice guidance document on how to do the phosphorus loading calculations. And that can be a really valuable resource also as you go through this process. It uses the methodology the EPA used for the Charles River community baseline loads also. But there are some differences in the guidance provided in that document and what I'm going to tell you here. And I've talked with Newt and Mark about this a bit, and you should be using the updated information in this presentation to supersede some of the information in that guidance. And I'll point out what those things are when we get to it. Okay, next slide. So the basic idea behind the phosphorus load export calculations is really simple. What you want to do is calculate your annual phosphorus export load, and that's equal to your phosphorus load export rate, and sometimes abbreviated as PLUR, as I mentioned a minute ago, and then you just multiply that by your area. So pretty straightforward. And next slide, Andrew. And the phosphorus loads get calculated separately for different types of areas. So the phosphorus load, we calculate the phosphorus load from the directly connected impervious area. So it's DCIA. We also calculate from pervious areas. And we also calculate it from another area that's not quite as obvious, which is your disconnected impervious area. So just kind of going back to the beginning to the directly connected impervious area, that's a good portion of your impervious area, but you're going to have some impervious areas that are not directly connected to a storm drain. Maybe they flow to like a roof drain from a house that splashes onto a lawn. You could probably make the argument that, hey, that's runoff from an impervious area, but it's not directly connected to a sewer. It drains to a pervious area. That would be disconnected impervious area. And the permit's not very clear about how to do those calculations. So I'm going to provide some clarification for that in here. Now for the DCIA, your phosphorus export loading rates vary by land use type. So it's based on if it's commercial, industrial, certain different types of residential density. For your calculations of phosphorus loads from your pervious areas, those loading rates are going to vary by land use type and hydrologic soil group. So this takes into account that some soils are going to be have more infiltrative capacity and be able to receive some of that runoff and infiltrate it. And some soils are going to have less of that, which means that more of it's going to run off and would have more of an impact on your phosphorus load reaching your storm drains. Okay, next slide. Okay, so I want to talk about the loading rates for a few minutes here. So this table 1.1-2 is from Appendix F, Attachment 1 of the permit. And this provides phosphorus loading rates for different land use types and for different soil types. And I've reformatted that in the table over here on the right. I think it's just a little bit easier to read in this format. So this shows the phosphorus loads for the directly connected impervious area by land use type. And then it also shows the phosphorus loading export rates for the pervious areas by hydrologic soil group and land use type. One thing to note is that the values, the phosphorus loading export rates for the pervious areas, you don't want to use these in your baseline phosphorus estimates. You use these for when you calculate changes due to redevelopment. So when you do your phosphorus, your baseline loads, don't use these values. That applies to both the Charles River communities and the lakes and ponds communities. I'll show you the values that you should use. Is it maybe the next slide? Can you go to the next slide, Andrew? Oh, no, sorry. I'm going to come to that a little bit later. So I'll return back and talk about the pervious phosphorus loading export rates in just a minute. But first, I want to tell you on the next slide what the goal of this whole thing is. So fundamentally, if you can calculate these values in yellow shown in this table, you can calculate your baseline phosphorus loads easily. And so all we're doing here in this table is calculating the total area for each of these different phosphorus land use groups, the impervious area, and then the pervious area for different hydrologic soil types. And once you have these values, you can just put them right into a spreadsheet and everything else gets calculated. And I have the spreadsheet. I'd be happy to provide it to you if you'd like. I'm going to show you parts of the spreadsheet as we move through this. But again, if you can calculate these yellow values for your area of interest, then everything else is pretty straightforward. And so what I'm going to do in the next few slides is walk you through the calculation of these areas. It's largely a GIS exercise. So these are the different GIS data sets that are readily available to you to do this analysis. MassGIS is a great resource. They've got land use data for 2005. And by the way, that's a really nice land use layer. I'll talk about it a little bit more later on. We've got soil types. We've got impervious area. Again, it's pretty remarkable. We have a state that develops this kind of data for us. That impervious surface area is for 2005. And then when it comes to the areas to ignore, so these would be your areas that are not under your jurisdiction. These would be like Mass DOT properties, DCR properties. There's a few different resources for those. There's a layer for DCR roads and trails. There's a Mass DOT layer you can use for roads. And then you might have other areas, maybe in your own GIS data sets, like your combined sewer area, perhaps. RDAs, if those are implemented, would be another area that you'd want to ignore because those aren't under your jurisdiction. So this is a layer that you have to compile a little bit yourself. And then it's also helpful to have the municipal boundaries. For the lakes and pond communities, you might have a watershed boundary or your catchment boundaries. Okay, next slide. Okay, I'm just gonna walk through some of the GIS operations here over the next few slides to show you how those areas that I showed you in a table just a few minutes ago were how you calculate those. So what you would do is take, it's convenient to start off with by just trimming the GIS data to your area of interest. And so that's what this slide's really talking about. So let's take your land use data. This is for land use kind of for the greater Boston area. And then we can take a municipal boundary like for Brookline, and then we can clip those so that we just get land use for Brookline. And we can also do this with the soils layer. And if your phosphorus control plan is only in your urbanized area, you would want to clip to just that urbanized area too. So it would be like your municipal urbanized area. Lakes and pond communities, this would be like your watershed if you're using a watershed, or it could be your urbanized watershed if that's your phosphorus control plan area, or it could be your catchments within your urbanized area. Okay, next slide. Okay, so one thing we need to do, if you remember a few minutes ago, I showed you this table here on the right, table 1-2, that has these phosphorus loading export rates for different types of land use. On the left-hand side, I'm showing you a table from the GIS data for the 2005, Mass GIS 2005 land use. And it's got this nice column that provides a description of the different land use types, and it has a code associated with it. The problem is these don't match up exactly with the phosphorus loading export rates that EPA provided, but they provide a lookup table so that you can match them together. And that's shown on the next slide. The table on the left, 1-3, is that lookup table. And it has the Mass GIS 2005 land use codes along with the description. And then the column on the right there, land use group for calculating phosphorus load, those are the labels on the phosphorus loading export rates. So the table I'm showing here on the right is an example of the GIS data. The stuff in white is the data from Mass GIS. And then the column in yellow is where I've used the table that EPA provided to cross-reference the Mass GIS 2005 land use types to the phosphorus land use groups that EPA provides phosphorus loading export rates for. Okay, next slide. So the next thing that you want to do is to combine your land use and your soils into one GIS layer. And these GIS layers individually, they're just polygons. So land use is just a bunch of polygons, and each polygon has a phosphorus land use group associated with it. And this, just as a reminder, the phosphorus land use group we just looked up a minute ago in that previous slide using the Mass GIS data to get the phosphorus land use group for the different phosphorus loading export rates. The soils, each of those polygons are hydrologic soil groups. When we union them together, we're basically kind of like laying these two layers on top of each other and intersecting them. And we're getting a lot of like new polygons, like smaller polygons. And each of those smaller polygons has both a phosphorus land use group and a hydrologic soil group associated with it, which is great. It's what we need for our calculations. Okay, next slide. The next thing we want to do is remove our areas to ignore. And just as a reminder, these are the areas that aren't under your jurisdiction. So for Brookline, they've got some Mass DOT roadways, some DCR roadways, they've got a DCR property. And what we want to do is basically do a difference operation on those two GIS layers to remove them. so that those layers don't show up in Brookline's phosphorus load calculations. Next slide. And then what we want to do is, once we've got this layer on the left, which is our combined land use and soils with all of the areas that we don't want removed, what we want to do is overlay the impervious area on top of that and figure out what the impervious area is in all of those little polygons in the revised land use soil layer. Okay, next slide. And once we do that, we can begin some of these phosphorus load calculations. So with the steps that we just did, we can calculate the total area for each of these phosphorus land use groups and the impervious area within each of these phosphorus land use groups. And this just comes directly from what, those GIS calculations that we did previously. And so we can put these in a table and we can calculate percent impervious. Now what we want to do is we want to figure out what's the directly connected impervious area. Okay, well, it's got to be less than the impervious area. Can you go back to the previous slide for just a second? So we know that the directly connected impervious area has got to be less than the impervious area, but we don't quite know how much. If we were doing this on sort of like a small neighborhood, we could probably go into a map and sort of map all this out and figure out what of the impervious area is actually connected to a sewer or storm drain. But that's pretty difficult when we're looking at a system this big. So what EPAs do has the approach they've taken, next slide, Andrew, is to use an approach that calculates the directly connected impervious area using the Sutherland equation. And this equation just says the percent directly connected impervious area is equal to some coefficient A times the percent impervious area divided by 100 to some exponent B. And the coefficient values of A and B are based on land use type. So for example, for commercial land uses, A is equal to 0.4, B is equal to 1.2. So if we had an impervious area for commercial land use that was 80%, then we would calculate the DCIA using that formula and we get a value of 77%, which is less than the impervious area of 80%. So what this is kind of telling us is that, hey, 3% of that impervious area is actually flows to pervious areas rather than directly to the storm drain. Okay, next slide. So EPA documented this approach in a document called EPA's methodology to calculate baseline estimates of impervious area and directly connected impervious area for Massachusetts communities. The link is provided here. That document discusses the approach, provides the coefficients, but you don't want to use the coefficients from that document. Mark Voorhees with EPA was the person who developed the baseline phosphorus load calculations. And he wound up calibrating those coefficients a little bit further. So what you want to do is use the values in this table here in order to be consistent with the values that were used for EPA's baseline load calcs. And these values were provided in a memo that Mark provided to me, and I've verified with him that these should be used for the baseline phosphorus loads. Okay, next slide. So this table is an expanded version of the one we were looking at before. The yellow cells are the ones that we had to calculate, that we had to provide. So those came out of our GIS analysis. The ones in light blue are calculated values. So we calculated the percent impervious. The Sutherland equation coefficients were provided by EPA in Mark Voorhees' memo. With all of that information, we can calculate the directly connected impervious area. We know what the phosphorus loading export rates are for each of these different phosphorus land use groups. We discussed that a little bit earlier. So all we have to do at that point is just multiply the DCIA by the phosphorus loading export rate to get the phosphorus load, the total phosphorus loading export rate. Okay, so at this point, we've calculated our phosphorus loads from our directly connected impervious area. And what we want to do now is calculate the loads from the pervious areas. So next slide. So this is the table we want to fill out in order to do the calculations for the pervious areas. And the cells in yellow are the ones that we calculated from our GIS analysis earlier. Now what we want to do is we want to fill in these phosphorus export loading rates for the pervious areas. Now earlier, I showed you a table from the permit that showed these values, and I said, don't use them. I'm going to come back to this and tell you why. So let's discuss that for a second. Next slide. So these are the ones in the permit, Appendix F, Attachment 1, Table 1.2. But you don't want to use these for your baseline phosphorus load estimates. You want to use the ones in the next slide. And I've color coded these to show you which ones are the same. Sorry, Andrew. Yeah, thank you. So I've color coded these to show you which ones are the same and which ones are different. All the ones in sort of the blue are the same. Forest and agriculture are different from each other. So, but all of these values are different from the table that I showed you previously. And the reason why these values are different is these values did not assume a reduction in phosphorus concentrations of runoff from pervious areas due to the fertilizer reduction requirement that was implemented a while back. So a while back there was a sort of a ban or a restriction on use of phosphorus bearing fertilizers on properties that basically don't need them. And so these values do not take that into account. And these are what were used in your baseline phosphorus load estimates. Now, we're going to talk about this in the next workshop. EPA had originally intended to put a credit for fertilizers into the permit. And this was actually in the draft permit, but in the final permit, it wasn't there. So we'll talk about this in the next session, but they expect in the next permit there to be a credit for fertilizer. And we can talk about that a little bit more in the next one. The reason why these values are different from the one in the previous slide is that the post-development condition, EPA did assume that there was a phosphorus reduction due to the fertilizer, the ban on the phosphorus bearing fertilizers. So there's a little bit of a difference between those two, but these are the values that you want to use for the baseline loads. Okay, next slide. So now we can plug these into the table, and then we just calculate our loads. Loads are the areas times the phosphorus loading export rates, and we can just sum all of those up. Again, once you just put the yellow values into this table, the spreadsheet kind of calculates itself and gives you your total load. One thing to note is that in the is in the soils GIS layer, there are some areas where you don't know where the soil types are unknown. And in those cases, you want to use soil type C, the phosphorus loading export rates for soil type C. Okay, next slide. Okay, so far we've got the phosphorus loads calculated for the directly connected impervious area and the pervious areas, but there's still an area that we haven't calculated yet, and that's the disconnected impervious areas. So I'm going to show you how to do that in the next slide. This one's a little bit interesting. So again, this is the table that you would use to do this. And you actually don't have to plug anything into this table. This table can use information that you've already developed from the previous tables. So the first column, or actually the second column under impervious area, is the total impervious area, and we've got directly connected impervious area. The disconnected impervious area is the difference between those two. So that's the area that we want to calculate the phosphorus load from, but we need to know what is the phosphorus loading rate from that disconnected area. Well, that disconnected area is flowing to pervious areas. So the way that EPA does it is they calculate a composite pervious area phosphorus export loading rate from your pervious areas, and then use that to calculate as the loading rate for your disconnected impervious area. So the way that you could think about this is that the phosphorus loading rate for your disconnected impervious area is really just kind of your average weighted phosphorus loading export rate from your pervious areas. And so that's all this spreadsheet does, is calculates that weighted phosphorus loading export rate multiplies it by the disconnected area to come up with the disconnected area phosphorus load. And this is something that's not covered in the permit, by the way. Okay, next slide.
Matt,
but it was, yes.
Matt, sorry to interrupt you. We've been getting a bunch of great questions in the chat, but two just came in that I felt like needed to be addressed right now before we lose people.
Sure.
People are getting a little bit confused, as it is confusing, about kind of which, I mean, we have one question, where can we get all the accurate tables and data being discussed? I can't keep track of which we should use and which we should not.
Yep.
And then someone else chimed in, can you please go back 2 sides to the plurs for the pervious area? I am confused.
Sure. Okay. So it is confusing. and so the values shown in the permit for the pervious area phosphorus loading export rates should not be used for the baseline phosphorus estimates. Don't use those. Show the values in the next table. Use the values in this next table. These are the ones you want to use. And Julie, I could talk with you about ways that we could provide some guidance. Like, I think it would be nice to have a guidance document that sort of summarizes these modifications. I think this workshop, you know, in its recorded form can hopefully help people, you know, maybe people who weren't here and people who want to go back and just kind of recheck values. But, you know, I'm totally open to helping to put together something like some written documentation if we want to do this too. I know it's confusing, and I apologize for throwing so much. There's just so much to try to cover in this. I'm open to...
I think people appreciate you taking that challenge on. Yeah, that's great, Matt. We can, well, this is a really good example of something we could also pull into the PCP template and just really call these things out explicitly using that. And then I see Lucica actually has her hand up. Do you want to, did you want to clarify something on your question?
Yeah, the confusion I have about these new sort of PLERs is, Matt, to your comment about the fertilizer. And these PLERs are higher than what the permit has, right? So
yep.
I guess I'm still confused because EPA already gave everybody the fertilizer credit, but now it seems like we want to redo our baseline, assuming that we are not taking the fertilizer credit. Is that what you're saying? Or I was confused about the fertilizer piece of.
Sure. So these pervious area phosphorus loading export rates, EPA assumed, I believe, a phosphorus concentration of 0.3 milligrams per liter in the runoff. And these values were calculated from that. So they did not assume a reduction in the phosphorus concentrations due to the fertilizer ban in these values that were used for the baseline loads. The values that are shown in the permit, they assumed 0.2 milligrams per liter concentration of phosphorus in the runoff from pervious areas. And those phosphorus loading export rates are lower because of that. So it's a little bit odd for the baseline conditions. They're giving phosphorus loading export rates that do not include the not take into account the fertilizer ban, but in the credit in the loading rates that you use for redevelopment, they do. And I'll talk about that a little bit more, where you actually do use the phosphorus loading export rates from the pervious area that they have in the permit. I'll discuss when you do use those.
Thank you for clarifying that this is just for the baseline calculations, not for the credit. Thank you.
Yep.
I got it now.
Yep.
Okay, thanks, Matt. I think we'll we'll definitely have time for questions. I just wanted to clear those up so people didn't get totally lost, but
yeah, no, thank you.
If folks don't mind, I think we'll just go back to it because it's already 2 o'clock and I know you have a lot to cover. So just a heads up on that too.
Yeah, no, we're getting there.
We're getting there. Good.
So, okay, next slide. Just, I believe, shows the total after we've done all the calculations. And again, you know, all these calculations, you know, look kind of, you know, complicated. There's a lot of detail and I wanted to know what goes underneath them. But ultimately, if you can calculate, if you remember that table we showed a little bit earlier with the areas that you have to calculate shown in yellow, like if you can just calculate those areas, you can put them into a spreadsheet. The spreadsheet has all of the values that I've shown you here. And we could, you know, provide that spreadsheet to you. You can reach out to me by email. I could provide that, or I could work out to Julie how we could, you know, make that a little bit more centrally available. And at Brown and Caldwell also, we've developed an application that's still under the works that does all of this also automatically. You just feed in the GIS layers and it can actually just pull them directly from MassGIS and it can do all these calculations for you. And you know, that's potentially something that we might be able to make available. And I can talk about that a little bit more at the end too, if there's any, I guess I'd be interested to see if people have any interest in that. So, but why don't we keep moving? We're running out of time here, but we only got really one topic left to cover, which is how to phosphorus load changes due to development. So far we've talked about the baseline loads and the, so Maria had a question. Does this table have a typo? Maybe it does. Can we go back for a second, Andrew? Yes, let's see. Don't think so. We have directly connected impervious area, disconnected impervious area, impervious area. So there's the loads from each of those. So I think that's right. But
I guess that second column, it just looks like disconnected impervious areas in there twice, or maybe there's different units.
Oh, I'm sorry. That is a typo. Oh, hang on. No. So DCIA is direct, disconnected impervious areas is different.
Oh, gotcha. Directly connected and then disconnected. Got it.
Exactly. Yeah, and it's very, they're almost spelled similarly. So I apologize for not making that clear. All right, so next slide. So we've talked about the baseline loads. The part we haven't talked about yet is the phosphorus load changes due to development. So the baseline loads were developed in 2005, but a lot has happened since then. And so what the permit wants you to do is to bring, for you to calculate what those load changes are, and then those load changes get factored into how much you have to reduce your phosphorus. And those load changes need to be updated annually in your annual report starting in year 5. So let's talk about how to do that. Next slide, please. So you've got 2 options. You can do a project by project approach. This is described in the MS4 permit, Appendix F, Attachment 1, and it's pretty data intensive. What you do is you go through project by project, you look at the land use for the project, your tributary area, your soil types, and you do your calculations to sort of like before the development and after the development, and that changes what you use to update your loads. But the problem is that because you need that project specific information to use this approach, you may have trouble finding all that project information from 2005 to 2022. So for looking back, kind of catching up to current conditions, you may be better off talking about option 2, which I'm going to talk about in just a second. And moving forward for future projects, you're going to be required to do this project by project approach. Newt has said as much. You know, going forward, you have to use the project by project approach, but option 2, Newt has said, you can use this as a way to kind of catch up to current conditions. And this option 2 is basically what we have done, we discussed previously for doing your baseline phosphorus loads. They're area-wide phosphorus load calculations, but you're just doing them with updated GIS layers. Instead of using 2005 impervious area, and 2005 land use, you're actually doing those calcs with impervious area and land use data for current conditions. And if you can just update those GIS layers, you can use the same approach used for the baseline loads. It's pretty straightforward, and that'll allow you to catch up to what your current loads are for existing conditions. But moving forward, as I said, that's not going to be an acceptable approach for the future. You're going to have to do the project by project approach moving forward in the future. Okay, next slide. So let's talk a little bit about the project by project approach. So what you're doing is you're calculating the change in the annual phosphorus load. And the way you calculate that is you look at the post-project annual phosphorus load. So that's after your redevelopment. And you subtract it from what the pre-project annual phosphorus load was. And so that difference gets added to your phosphorus load target. Now, one thing to note is that if your phosphorus control plan area is for your full jurisdictional area, this applies, you're going to have to do this for all of your projects. However, if your phosphorus control plan is for your urbanized area within your jurisdiction, you only need to do this for projects that are in the urbanized area. Okay, next slide. And I just want to show you an example of how this would work. So let's say we've got this little schematic over on the left column of a site before development where it's a forest, and then post-project where half of that forest has been converted over to medium density housing. And you can see my little sketch here of like road and some houses and some catch basins. And I wanted to just kind of walk you through the different layers that we use to do the project by project calculations. So one thing we look at is impervious area. You can see for the pre-project site, we've got no impervious area. Post-project, we've got about 1/4 of an acre. And then we've got our directly connected impervious area. None before. Afterwards, we've got our roads. We've got our disconnected impervious area. We've got none of that to start with, but afterwards we've got these houses. We've got the rooftops. Those are draining to the yards. So that's disconnected impervious area. We've got our land use layers, and we've got our soil types. Notice soil types don't change before or after. And by the way, when you do this project by project approach, you don't use the Sutherland equation. That's for area-wide calculations. When you do this project by project approach, you're on a small enough scale that you'll actually be able to figure out what's the disconnected area yourself through maybe field investigations or looking at GIS data that's available. Now, next slide, Andrew. So when you do this project by project approach, this is when you use the phosphorus loading export rates for the pervious areas shown in the permit. These are the ones that take into account the phosphorus, the phosphorus ban in fertilizers. So these are the lower rates. So just to repeat, when you do the project by project approach, you use the phosphorus loading export rates that are in the permit. Okay, next slide. So what I've done is I've just taken the values from the schematic that we were looking earlier and filled in these yellow cells. So like total area, impervious area, directly connected impervious area. I did that for both the pre-project condition, which is the table at the top, and the post-project condition, which is at the bottom. And this is just a simplified spreadsheet of the one that we were looking at earlier. I've removed a lot of the hydrologic soil group columns that we don't need, you know, A and D and C/D and unknown, to just make these tables a little bit smaller and easier to read. And there's a lot of info here. I don't want you to have to read all of these. The bottom line is that when you do these calculations for the post-project condition, we find that the annual phosphorus loading export rate was 0.77 pounds per year. Doing that for the pre-project condition, it was 0.39. So that's a net gain of 0.38 pounds per year of phosphorus after this project was implemented. And assuming that the phosphorus community's phosphorus load reduction load was 100 pounds per year for their baseline condition, now that this project has happened, that load reduction has increased to 100.38 pounds per year. Okay, next slide. So this is just another little nuance to this. If you're a lakes and pond community and you're doing your catchments instead of your watersheds, and the case that we looked at before was a forested area, which would not be part of a catchment because there was no storm drain running there. So it would have a pre-project load to your system of like 0 pounds. But for when you do the project, you're going to have to extend your catchment boundary. So as you do that, now you've got new land coming in to providing a phosphorus load that wasn't there before. And so now you're going to have a load of 0.77 pounds per year minus 0 pounds per year beforehand for a net load increase of about 0.77. So this is just one thing to think about if you're a lake and pond community and you're using subcatchments. This development may actually require you to extend your catchment boundaries, and that's going to increase your load a little bit because of that, because you're incorporating land that wasn't previously going to your storm drains. And I think that might be, okay, just one last word on the project by project approach. EPA's released a tool called the BAT tool that can help you with all of this. And there's a link to it here. And then the next slide, I think, is my last one, which is just to talk about the option 2. Instead of doing the project by project approach, if you want to catch up from 2005 to current conditions, you can update your GIS layers. And you can do that, each year. Well, actually, you would just be doing it. If we're just doing it for catch up, you'd be doing just to current conditions. One thing to note is there's a 2016 land use GIS layer, which you would think would be, better because it's newer. But I have to say that I've looked at both, and I've looked at both the 2005 and the 2016, and I'm really impressed with that 2005 land use layer that they developed. It has some really nice advantages to it. And if you update that, I think you might be better off. Just to give you an example, the 2005 GIS layer actually codes real land cover types. So you have forest, you have residential. The 2016 is really based more on parcel data and the land uses assigned to parcels. So you could have a really big parcel, a residential, maybe a low density residential parcel that if you look at the 2016 data, it's going to have that land use code, low density residential parcel. But if you look at the 2005 data, the land use, you may have forest, half of that being counted as a forested area and half of it being counted as a residential area. And I think that's a real advantage of the 2005 layer. It's really looking at land cover type as opposed to categorization of parcels into a land use type. So I think that, I know that, so I just wanted to say that maybe people might want to talk about that and share their opinion too. But the way that you can update those layers is through orthoimagery, like MassGIS has a great track record of releasing frequent orthoimagery. Nearmap is another great source. It's a paid source, but it's really good. You can also use building permits and other info. And some of the nice things about taking this approach is that updating your impervious area helps support a lot of other things like a stormwater fee, stormwater modeling, heat island analysis, resiliency planning. So there are some nice benefits from taking this approach that go just beyond, helping you catch up with your phosphorus loads due to development. Okay, next slide.
Okay, let's see. I think I am going to, we only have 13 minutes left and people have questions.
Okay.
So I think we're gonna actually have to table the breakout rooms for right now. I would just hate for these questions to not get answered, especially after folks giving us an hour and 15 minutes of their time. So we have questions in the chat. We have some hands raised. I was just going to try and go through them in the order they came in. If that works for you, Matt.
Yeah, please. Yep.
And some of them, this first one has actually been answered in the chat. I'll just read it. Matt, give you a minute to rest your voice too. But the very first question was, can you please confirm if EPA will accept the recalculation of baseline as done by communities, or do the communities need to submit the updated land use and impervious area layer to EPA for them to perform the baseline recalculation? And Andrew, thank you, answered that in the chat, saying that EPA will recalculate using their methods, which we are discussing. And the data provided by the permittee. Next question, are the jurisdictional breakdowns the EPA used available online?
So the jurisdictional breakdowns,
I don't know if that means jurisdictional, like jurisdictional area, or Matt, if you want to clarify on what exactly that means, like the regulated area.
So if he's referring to the jurisdictional boundaries, those are available through MassGIS. So I would presume that's what EPA used for the jurisdictional boundaries. The urbanized areas there also. So I'm not sure if that answers the question, but.
Yeah, I mean, I'll just weigh in. If you are looking for the regulated area, we just ran into a slight issue with that because I think they used regulated areas from a few different, they actually combined a few different areas, excuse me, a few different layers to do the regulated area. So maybe that would be a good one to clarify in our, either before or in our regulatory Q&A session. Tom asks, where can I find this list of lakes and ponds?
So I think that, so they're listed in the permit, but there are also some additional lakes and pond communities that were not listed in the permit that have watersheds that are covered by the permit, but they weren't listed. And Julie, I think that you guys put together some guidance on this.
Yes, this is a list of towns that are all or part of a watershed of one of these lakes and ponds. And then I guess there's also the list of the actual lake and or pond that has the TMDL elsewhere in the permit. But this is the list of towns that would have overlap with some of these watersheds.
Okay, can I ask a follow-up question?
Sure, Tom.
What was the criteria to focus on certain lakes and ponds? I don't see Sherborne listed, and we have a 126-acre Great Pond, and we're not listed.
Yes, these date back to some total maximum daily load or TMDL studies that Mass DEP did years and years ago. So we have the Charles River nutrient TMDL study that, you know, applies to our watershed. And then Mass DEP also did some nutrient TMDLs for, I'm forgetting how many it is. I don't know if you remember off the top of your head, Matt, but for, I don't know, like a dozen plus lakes and ponds throughout the state. And so they have TMDLs. So because these water bodies have these TMDLs, this applies to them. How these were selected out of all the lakes and ponds in the state, I do not know.
So if our lake is in the Charles River watershed, we can ignore it?
Yes, you're basically, you would be subject to the Charles River requirements. Yes, yeah, good clarification. We covered this, it is confusing. DCIA is directly connected impervious area and then disconnected impervious area. So hopefully we cleared that one up. Dave asks, did you outline the threshold for what is classified as high, medium, and low density? Oh, that must just be referring to the land use. Yes, Dave, that is outlined when the Matt jump in here, but for the 2005 land use layer that you were working with, yes, that is defined. Those subcategories are defined. You can find that in the MassGIS info. Basically, it's based on, okay, yeah, and this is how it maps to the permit. So great. So yes, that is defined. Okay, and then these are the two we paused on here. Just get how do they know when to use this? This memo has thrown everyone for a loop, Matt. So we'll make sure we'll make sure that's clarified. And then Zach, can I suggest another approach entirely for near-term targets for discussion? And Zach, you also have your hand raised.
Yeah, it's the same thing. I thought we were going till 3, Julie, for this. No? I have on my calendar till 3 anyway. So, I mean, I think there is a lot to discuss here. You know, Matt, thanks for the presentation. I am a little confused about this baseline load characterization. And because we have EPA on the phone, I think it would be a good opportunity. And we have so many of the permittees on the phone. It's a good opportunity for us to discuss as a community of practitioners trying to figure this out. So, a lot of this calculation doesn't get us one step closer towards a cleaner Charles River, for one, right? And then in the permit, in Appendix F, it says we can submit new data if we want to. And it says, until such time as future permit requirements reflect information submitted by us, the permittees or their consultants, we should use the tables that are here to calculate compliance with milestones. So I guess I want to go all the way back to the start and ask the question, do we need to do any recalculation of baseline? Or can we begin to plan structural and non-structural BMPs to address the compliance schedule that's written in the permit? I don't know if in a court of law, all of these calculations are going to be something that we're going to need to plan towards. So I guess I'm just wondering, I'm just begging the question of why we would go through the effort to recalculate all of this for a baseline load. I understand land uses have changed, but quite frankly, with the load reduction and targets that we have, a lot of communities are going to struggle to get to year 8 anyway, regardless of changed land use. And so I just want to kind of throw it out there for us to talk about. Do we really need to calculate and recalculate baseline, or no, can the number in the permit?
Yeah, no, you don't need to. The lakes and pond communities need to. Because that's part of their requirement. But for the Charles River communities, you don't have to. But there are cases where you might want to. One of which is that if you find that if you want to make a request for a revision of your baseline phosphorus load, that would be a situation where you would want to redo the calculation and see if you could make a case. And again, just to be clear, you have to submit your layers to EPA to do the calculations formally, but you can still do it yourself. The cases where you might want to do that, I think, are primarily going to be if EPA hasn't done the accounting correctly for DCR and DOT properties. In Brookline, I found that they missed a relatively large DCR property. And it's, EPA has, sort of limited access to community data. They don't know who owns all of the parcels. And if you can reduce your load by, 100 pounds, 50, 100 pounds, that's a pretty significant savings from a cost point of view. The other thing is, if you want to catch up to current conditions, I think that this sort of baseline phosphorus load calculation estimate approach is a nice quick way to do that, to bring you up to current conditions with up-to-date GIS layers. So I think that would be the other reason why when you would want to do the update. It's not like you would want to necessarily calculate a revision of your baseline loads, but it's very easy to do if you're going to do it for bringing yourself up to current conditions, because you've got everything set up to do the calculations to begin with. So
yeah, I appreciate that, Matt. I know you've thought a lot about this. For me, a little bit is like, these numbers are export, there's all kinds of fuzzy math in here. This is not fate and transport modeling. This is not accounting for sinks in the landscape. So, so it's good. It's good enough. And Mark's done a great job of helping us get where we need to kind of think for planning purposes. I mean, ultimately, we have a massive hill decline here, and a lot of the accounting piece of this is going to be very, very tricky for a lot of communities. And so I guess I just want to suggest that maybe we keep it simple as much as possible. Focus on the things that will get us credit. Focus on making a difference for the Charles River, and less on doing the modeling, if you will. I guess that's our approach, our thought on this. And we're doing the calculations as best we can, but there's a lot of moving parts in here. I mean, I've been, chatting about the highway land use category in the 2016 data. We don't even really have a good way to calculate that right now. So, I mean, we have some guidance from Laura and Mark on that. I appreciate that. But, there's a lot of challenges to calculating the actual impact of phosphorus. And I guess I just want to put that out there. It's, it's a difficult thing to do. And so, we have a lot of planning work to do. And I think the numbers that are in the permit are defensible. I think EPA did a good job. They did whatever they could do to come up with those numbers. And frankly, that's how I want to plan, is based on those numbers. I don't want to spend a lot of time recalculating personally. So just my take.
I think it's also, Zach, maybe worth pointing out that there's two different pieces. There's the baseline of what happened in 2005, which is where a lot of what Matt is talking about of what the actual values that they used are. So what that table that we had up before, comparing what was in the permit to what's not in the permit. Then there's 2005 to present. That's all using the permit numbers. There's no question about that. That's the fertilizer credit stuff comes into effect. You use all that information. We're not challenging that. But if there is a case for reevaluating what happened in 2005, like Matt said, if they missed some DCR lands, doing this analysis and getting a baseline recalculated and maybe giving you some relief on what the actual requirement is, because that information was not as accurate, like that might actually be a more cost-effective way to reduce to lower your credit requirement compared to actually implementing BMPs. So that's kind of looking at that big picture and starting the planning from what's all the data you have and how much phosphorus is actually coming out. That's kind of why we're trying to go through this thinking, if it's worth it. Again, if all the DCR stuff is the same, not necessarily worth it for a community to recalculate their baseline.
Thanks, Stephanie. All right. So yes, it is 2:30. I can definitely stay on in case folks really do have a tight timeline. Thank you for joining. Again, we will stay on and address the rest of those questions, but just in case you had another meeting, quick plug for the upcoming workshops. And then reminder, we are looking for your data on costs of BMP and benefits, particularly phosphorus reduction benefits. You have three options to give us those data: an Excel sheet that we created that you can just fill in, files that you have that we can hopefully pull the information that you can either email to myself or Iris, whose email address is here, or submit through a Google form that many of you receive via email. If you didn't, you will get it after this workshop, if you didn't yet. Or if the easiest thing for you is to just get on the phone with us, you can also request that through the Google form link. We have a full website where all this project information and the recording for today's workshop will be. That's where all the links to register for future workshops are, and the PCP template, which again, we're really hoping can really serve as kind of the house of all of these resources, and nuanced nuanced subtleties here that go along with this permit. Also on that website, you can submit your questions for our Q&A session with the regulators. They didn't stay on today. They felt like if they were on the whole time, people might, I don't know, be worried about what kind of questions they were asking, or maybe wouldn't even feel totally open to answer the poll questions, although those were anonymous. So they actually were just sort of giving today their seal of approval and then getting on with their day. But the Q&A session with them, obviously they will be on the whole time. The more advanced info we can give them on the questions we have, the better they will be able to prepare. So it seems like some questions from today, maybe just ready to pop into that form as far as, why they chose to do some of these things. Great. All right. Well, I will say bye to those that really have to jump, and we will continue back to our questions. Let's see. So Luchicha, you actually had the next question and you have your hand raised. You want to,
Hey, Julie. My name is pronounced Luchika. Just
Luchika, thank you.
No problem. I had my hand raised because I wanted to ask a question regarding the, well, I actually wanted to make a comment. I speak for myself, for my community, so I don't want to speak for any other community, but one thing that I want Matt and sort of the other consultants on this call to think about that our communities have been developing for the past 15 years, right? Doing the development calculations, at least in my mind, and I haven't done them, will mean that our baseline load, right, with all the development will go up. So I just want to make sure that people understand that, yeah, DCR, EPA might have made a mistake with one community because they didn't include a big DCR community and their baseline might be lower, but I'm reluctant to think that that's true for all the communities and all our loads will go up. And then how do we meet the year 8 numbers if we're calculating, you know, from this? And that's sort of something I wanted to bring up. And my question that I put in the chat earlier is a rhetorical. How do we catch up on BMPs since 2005 to 2022, right? If we're catching up on development, how do we catch up on any type of BMPs put there? So something for discussion, or maybe something for EPA to give guidance, because how do we go back 15 years to get those numbers? We won't be able to.
Great. Thank you for sharing those comments. And actually our next workshop on private BMPs will talk a little bit about how you might catch up. All right, and just a clarifying question from Teresa. Can you please explain the disconnected areas again? So what is the disconnected impervious area?
Sure. So if we have impervious area, the idea is that some parts of that impervious area are directly connected to storm drains, like, for example, like roadways. But there might be impervious areas that aren't directly connected, and we call those disconnected impervious areas. An example of those could be like a roof that has downspouts that just splash to the yard instead of directly connecting to a storm drain. So when it rains, the water hits the roof, goes down the drains, then it goes into the yard, and then has the opportunity to infiltrate there rather than running directly into a storm drain. So those areas that aren't, those impervious areas that aren't directly connected to a storm drain, we call disconnected impervious areas.
Great. Thank you for that
I guess
clarification.
My question for that one is how do you determine, is you just need to go through house by house, because some areas will drain into a storm drain, others will go. So is there an easy way to calculate your disconnected areas, or is it just really the truly obvious ones?
Yeah, no, good question. So there's two ways to do it, and it depends on sort of what scale you're working at. If you're working at sort of, let's say the watershed level or a jurisdictional level, like that's a big area. You can't really be expected to go, house to house and try to figure out, every one that's connected. So when you're working at that level, what you do is you use the Sutherland equation. And the Sutherland equation allows you to take the impervious area for a land use type and to calculate what proportion of that impervious area is actually directly connected. And the portion of that is not directly connected is your disconnected impervious area. And I'm happy to go into that more if you've got more questions about that. Now, if you're working at a small scale, like maybe a neighborhood scale or sort of like a project scale, maybe you've got like a particular site. In those cases, usually you're actually going to go in and you have the kind of data that you would need to actually specify directly what those disconnected impervious areas are. For example, you could go and you know, take a look at that house or that structure, that building, and see, are its downspouts, are they splashing to, you know, a lawn? Are they going directly to a storm drain? Or, you know, you can sort of investigate all those impervious areas, try to figure out which ones are going to the storm drains and which are going to pervious areas.
So say it's going into a swale. So we've got a number of parking lots that are fairly large and going into a swale. Does that, where does that fit, I guess?
Okay, yeah. Okay, so I think that that's up for interpretation a bit. In that kind of a case, I think you could make a good case that that's a disconnected impervious area. Because that's wholly the intention of that swale, is to try to, or at least I imagine it is, you know, to try to get some infiltration of that runoff from that parking lot. But I think that there's nuances here. And so, you know, we could, you know, it's probably going to depend a bit, you know, case by case.
Okay, thank you.
Okay, I don't know if you have any more to say on this, but Maria asked if you have a sense of how many of the Charles communities should develop their own baseline TP load versus using what EPA gave them. Sounds like a lot of folks are already sort of made the decision to just move forward with their permit baselines. But anything else to say on that topic, Matt?
No, not really. I mean, I think it's up to the communities. I mean, the cost of removing the phosphorus is so expensive that I think I think there's some advantages to doing the calculations. You know, one of those advantages of which is sort of catching up to current conditions by using the same approach with just updated GIS layers. So I think that, you know, given the scope of the phosphorus control planning and the cost involved, I think that the recalculation of the loads is a relatively simple thing. In fact, we've got a tool that, you know, can do it, you know, automatically. So it's you know, it's really not too big of an effort.
Okay, great. Thank you. Makes sense. Catherine asks, what is the status of the RDA? And apologies, we were going to talk briefly about this in the breakout room and just ran down on time. But no updates on the RDA, which stands for Residual Designation Authority, which would potentially require some private sites within your communities to essentially deal with their own phosphorus reductions for their own sites, and thus alleviating the municipality from that phosphorus reduction, or the phosphorus reduction, that load, I guess you could say, that comes from those Residual Designation Authority sites. So no update to report though. We're still waiting to hear from EPA on next steps on that. All right, next question, also from Catherine. Where do we find out the details on how EPA calculated P load for each community? Oh, how do they know how much MassDOT or DCR area EPA assumed for their community?
Yep, so we've got a table in the presentation that displays that. Yep, thanks, Andrew. And, you know, be happy to, you know, you could grab a screenshot of this, you could look at the presentation, you could email me, I'd be happy to give you the numbers for your community, whatever's easiest.
Great, no, that was great. Good straightforward answer on that one. All right. Okay, question 1, baseline reduction for pond and lakes. Is it from now moving forward or from 2005? And then this is also from Teresa, her question 2. If I'm in a red listed town, what percentages do we need to reduce?
Okay, so the first part of the question is related to, you know, the baseline loads and kind of current conditions. So what you would need to do is, for the lakes and pond communities, you need to calculate your baseline loads for 2005 conditions. You multiply that by whatever your reduction target is. That gives you your baseline load reduction that you're required to meet. But then you need to look at the change in phosphorus load from 2005 to current conditions. So if you have a net increase of phosphorus load during that time, you need to add that on top of your baseline phosphorus load to get your total phosphorus load reduction requirement. So you need to do the calculation for baseline conditions, and then you need to do it for current conditions. Now, an asterisk on this is that when I say you need to calculate it for current conditions, I laid out two different options for ways you could do that. You could do it project by project, or you could do it sort of that area-wide recalculation. So when you go from 2005 to current conditions, you can use either of those approaches.
So then your percent reduction is going to be for what it is currently or when the permit was issued. So where does that fall? Because we actually have put in a number of BMPs already. Okay, great. So, and we'll get into a discussion about the credits for those BMPs, I think in the next workshop. But in terms of just how your loads have changed due to development, you would take your 2005 baseline load, multiply it by your reduction target, and that gives you your baseline phosphorus reduction load. And then you need to add any phosphorus loads that, any net phosphorus load increases from 2005 to current conditions. And that's your total phosphorus load reduction. Does that make sense? Andrew, could you go to the slides that were kind of like earlier on in the presentation that sort of show the phosphorus load is equal to the 2005 times the reduction target? Do you know the one I'm talking about? Yeah, thank you.
Teresa, are you, since you're saying we're a town that wasn't originally listed in the permit, but may overlap or does overlap with one of these lake and pond, you're not clear on your reduction? Is that the question?
Well, part of our stuff goes into a pond that's in Hadley, and I know that one is listed, and I did not realize that Amherst has another TMDL, which I'm not sure where that is. So I've got to figure out where in Amherst or what pond, and if we actually send anything to there. And if we do, what percentage do we need to reduce from that standpoint? So does anybody know where to get that information?
I see. Okay. So you're wondering what your percent reduction target is?
Or even to find out what town or what pond or lake is affected.
Okay.
That we can help you with, I believe. If you want to shoot me a direct email, I'll just put my email in the chat. But then how do they find, for the lake and pond communities, are the phosphorus reduction requirements listed by lake in the permit, Matt? Is that once they figure out the lake and or pond, is that where they would go?
Stephanie, can you help with that question?
Yeah, so for most communities, each town and its corresponding lakes or ponds are listed in attachment Appendix F to the permit. CRWA actually went through an exercise and went and looked through all the TMDLs to kind of basically cross-check with the permit all water bodies with phosphorus TMDLs, and essentially found those. Andrew, if you want to go to the slide with the lake and pond with the red towns, but basically found like those 5 or 6 towns in red that were not listed in the permit, but technically are still held to the Appendix F because they have a water body with a phosphorus TMDL. We spoke with DEP about this, and Laura was aware, and I think she was going to reach out to all of the communities, and we can circle back with her because it's not in the permit. So I think it probably is a conversation with with DEP on which water body, but I'm sure it's probably also in the 2018 impaired waters list as well. But we can circle back with Laura because I know we had talked to her about that, about those 5 communities.
Because I am a university, and so because we're part of Amherst and at the town of Amherst, I'm not sure where we fit into all of this.
Okay. Yeah, so we can help clarify just with these sort of which lake goes with which lake and or pond goes with which town, which I guess sounds like it might be a place to start. And then, yeah, just second what Stephanie said, that DEP also would probably be involved, or a good next step for folks to talk to. So Stephanie, I saw you said, my apologies, I confused myself, disregard my question. However, I think your question might just be worth addressing just to clarify, just because this does get confusing. She was just asking about BMPs added after 2005. Do you want to just maybe say a little bit about that, Matt? So what if, obviously, it's many, many years since 2005. We've had a lot of environmental regulations in place predating the MS4 permit that have required a lot of stormwater management. And so a lot of the sites in communities do already have some stormwater management. I think that we're going to dig into this in the next workshop, but I guess, do you want to, maybe if you could just say something a little bit about how that might relate to what you went over today?
Sure. So any BMPs that have been, structural BMPs that have been implemented since 2005, you should be eligible for a credit. You'll need to calculate what that credit is. And you can do that with the, the permit does a pretty good job of laying out how that calculation is done. And you can also use the BAT tool to help with that. I don't believe structural BMPs prior to 2005 would be eligible for credit because the reductions from those would have been seen in the data that was used to develop the TMDL. So it's really BMPs after 2005 that you can get the credits for.
Hey Matt, I don't think that's what I'm hearing from EPA.
Oh really? Okay.
Yeah, because I don't think they had the data to incorporate that into the TMDL. So that might be a clarifying question we could have at the roundtable with them so that we get that out in the open. Different consultants are thinking about it different ways. And so it might be good to talk about later.
So you're
thinking... I agree. I don't know that they have a start date on that. I think they're looking for BMPs that are working
right.
Whenever it came or didn't come. But agree with Zach's suggestion. That would be a wonderful clarifying question for our Q&A.
There's probably not a lot out there that's really all that creditable prior to 2005. We just had different design features, but there's probably some wet ponds and big wet ponds around.
Great. So I guess, and Matt, maybe just to build on that, if folks are using your catch-up method as you went through here, they might also want to identify those BMPs that were put in during that time period. Is that the right way to think about it?
Oh yeah, yep, absolutely. So we talked about kind of catching your phosphorus load up to current conditions, but the other part of that, looking kind of project by project at how development changes things. The other thing you would be doing at the same time usually would be looking to see what the phosphorus reduction credits are for the BMPs that you implemented as part of those development projects.
Great. And so we will dig into that a bit more at our next workshop. Excellent. A little discussion on the lakes and ponds and the 303D list. Yes, the 303D list lists impaired waters as well as water bodies that have a TMDL. So these would all be listed on one of the various list categories. Let's see, another vote for clarifying on what BMPs that are in the ground folks can get credit for. And the last one thought I had, asking EPA to do the baseline recalculation is the same as current condition P loading. Is it not?
The baseline calculation is based on 2005 GIS layers. So
right, but if you're asking EPA to do the recalculation, you're supposed to submit them more updated information.
There would be more updated 2005 layers. So for example, the impervious.
Are you sure?
Yes.
Yeah, 2000. Yeah, so the baseline condition is 2005. So the intent is that if the land use data that EPA used for 2005 was maybe inaccurate, you could revise that and send that to them and they would recalculate the revised load. Same thing for impervious surface.
So all of the moving forward from 2005 to present is based, it's only changes, it's based on what they assume. So when you're recalculating the baseline, you're recalculating their 2005 assumptions, or you're sticking with their 2005 assumptions and adding on, but either way, the kind of number, you have a number for your baseline, plus or minus, usually plus development till present. The thing that the EPA is calculating is only the 2005. Right, is that fair, Matt?
Yeah.
EPA is not touching the present conditions.
Correct. Did that answer your question, Lucia?
Yeah, I'm having a hard time to believe that we could even have 2005 data that we can even give EPA at this point, right? In 2022 for this line recalc.
So the way that I did it is that I went through, I took the 2005 GIS data sets that are available through MassGIS, and then I used ortho imagery from 2005, and then used that to update the impervious surface layer and land use. Sometimes communities will have, parcel data with land use data, dating back that far, but really, a lot of times the ortho imagery is enough to see whether or not, the area was a forest versus a commercial area or, whatever kind of discrepancies there might be. But
did EPA not use the ortho from 2005 to develop the impervious area?
They used,
Sorry, I'm asking very detailed questions. We could take this offline too. I don't want to take everything.
No, and I'm happy to talk more with you about it if we can't get it all covered here. But I don't think the ortho imagery used for the 2005. So when you do the impervious surface analysis, you're measuring actually different wavelengths than you would when you do regular ortho imagery. So I suspect that they were different data sets, but I can't say for sure. But they are from the same time period. So the idea would be that you would, take the 2005 ortho imagery, kind of visually check it against the 2005 land use or the 2005 impervious surface area. And, it seems like a big effort, but I've done that for some communities, and it actually goes pretty quickly. Like in a day or two, I was able to, revise both of those layers. And, there were some differences and they were valid. So
I think
were they all lower?
Worry, yeah, that was my question. Thank you.
What's the question?
That's probably what everybody wants to know.
I don't want to open this can of worms. It's not.
Sorry, Matt, and sorry, Lucica. Were they all lower? The ones you cross-checked, were your calculations all resulting in? I guess it would be a higher baseline, right? And then your
the ones I have done have been a little bit lower, yes. Not dramatically, not 15-20%, but a little bit lower, yeah.
Then Matt, once you added in development, was it like a break even? I think that's kind of what Zach's getting at. It's like how much effort, like to do this, it sounds good. Like we all need to decide what is our starting point. because we all have to like have a record keeping system from whatever you decide your starting point is. 2005, stick with EPA, or, you know, bring it up to speed. So I think that's the catch-all, is like, if I'm understanding it correctly.
Well, you know, you have to bring it up to current conditions. So you have to start with the 2005 and then calculate the difference between 2020 and 2005, add those together, and that gets you like, okay, here I am. You know, this is how I'm moving forward. But I'm not sure if I'm hitting the right point there, Maria. So please let me know if I'm not answering the question.
I guess just basically on the towns that you checked, the communities that you checked, and you said you found some errors. Okay. And you found that a reduction was, the baseline load was actually reduced. But then when you added in development during those years, was it a wash?
I'm sorry, my brain's getting tired.
That's okay. It's technical.
The first part of your question, So yeah, it went up a little bit, but not as much as I expected it to go up. And so I believe that it was probably, you know, I'm thinking about one of the communities, I think it was about even after I added in the development up to current conditions, put this community about where they were at the baseline. So it was about even. But if we hadn't done the revision for baseline, or trying to make the case that we can do a revision for baseline, then they would be that much higher, you know, for current conditions. And I can't remember the exact number of pounds, but you know, it wasn't inconsequential given the cost of phosphorus control. So.
Got it. So basically, you're going to have to show that development happened either way. So you have to decide whether you want to redo. It's a very community specific decision whether to redo the calculations.
Oh yeah, absolutely.
Okay.
I mean, you know, you could do them and find out that it's really not much of a difference. I'm sorry. Go ahead.
I think one thing that I'm realizing right now, Matt, of what you're trying to say and do finally after 2 hours is if your baseline is lower, right, then also what you're required to meet at every step in the phase 1 and 2 and 3 of the PCP would be lower as well, although you do add the development, which you have to no matter what.
Absolutely. Yeah. Absolutely.
Some food for thought.
Yeah, and am I correctly also characterizing that that folks have, I mean, essentially you may be offloading on DCR or MassDOT. That seems like the other.
You should be. You should be. Like, you're not, this isn't a shell game. You know, you're not saying, oh, nobody has to take care of that phosphorus load. It's just disappearing. It's going to the entity that actually has control over that phosphorus load. So, you know, I think there's a good case for doing that.
Yeah.
It's like the RDA.
Yes. Yep. All right. Well, now we are at 3 o'clock. So thanks to those who were able to stick around, and hopefully it was helpful and you got your questions answered. We will hopefully see everyone on April 5th, I believe it is, at our next session where we talk about private BMPs. You'll get a follow-up info, a follow-up email, as well as the website that we mentioned before, which is on CRWA's website. You can access it from our homepage, and we'll post all the information there as well. Excellent. All right. Nice to see everyone. Have a great afternoon. Thank you. Thanks, Matt.